Good morning, guys. Welcome to part 2 of our combustion with a twist. So what I would like to do is to go ahead and set up a second problem for you. And in this second problem, it is very similar to the first one we did, except when I look at it, you can see that it says a compound contains carbon, hydrogen, and nitrogen. Combustion of 35.0 milligrams of the compound produces 33.5 milligrams of CO2, 41.1 milligrams of water. What is the empirical formula? So it's set up very similar in that we're going to go through and we're going to set up a mole-mole ratio using our carbon and then a mole-mole ratio using our hydrogen. But guys, look, if I was to take this, instead of just to the moles up here, if I was to use the molar mass of carbon or the molar mass of hydrogen and take it one more step, I could determine how many grams of carbon, how many grams of hydrogen that I would have in my initial hydrocarbon. So bottom line is, just adding one more step, if I know that my compound is made up of carbon, hydrogen, and nitrogen, I know the grams of carbon, I know the grams of hydrogen, I know the total grams, I should be able to then determine what the number of grams of nitrogen is. So I'm going to set this up starting with my 0.0. Let me start back over here, and I'm not going to use 35 and I'm going to use the grams of CO2, 3.5. So that's going to be 0.0335 grams of CO2. So now when I do my grams to moles, I use the molar mass of the CO2, which is 44.0. My mole to mole ratio is going to be the moles of the carbon, which is 1, moles of CO2, which is also 1. And then this time we're going to take it one more step, and I'm going to use the molar mass of my carbon, which is 12.0 grams per 1 mole, and I'm going to say is equal to, and when I do this, I am going to get 0.00914 grams of the carbon. So guys, if I come back up here and I do the same thing with the 41.1, I'm sorry, let's change that to grams. I did, I just didn't write it down. 0.0411 grams of my water, and I'm going to say moles per gram using the molar mass of my water, and then this time my mole to mole ratio is going to be to hydrogen, and I'm going to factor out that of the water. The hydrogen, I have to have 2 to those for every 1 of the waters. And then finally, I'm going to take it to grams per mole using 18.0 per 1 mole. So when I do that, that is going to give me, and I'm just going to go through and write it down. I've already got it, 0.00461. So guys, I know that this has to be made of carbon, hydrogen, nitrogen, and all of those added up has to give me 0.035. So if I take 0.03, turn my calculator back on, 0.035, and I subtract 0.00914, and then I subtract 0.00461, then that should tell me how many grams of my nitrogen I have. And I have I'm just going to go ahead and write that down, 0.0213 grams of nitrogen. Alright, so guys, all of these are going to be back in my grams. Well, in order to do this, I have to do a mole to mole ratio. So what if I was to come back up here and say, look, I have 0.00914 4 grams, and that's going to be of carbon. If I wanted to change that to moles, I could do it by dividing by 12.0. So if I did that, I could come back up here and say simply 0.00914 divided by 12, and I get 7.62 times 10 to the negative 4th moles of my carbon. Let's do the same thing with my hydrogen. So I'm going to say 0.00461 grams of the hydrogen, and then it's going to be a mole per gram, and that is 1.01 per 1. So I'm going to say 0.00461 divided by 1.01. And for the hydrogen, I'm going to get 0.004 6.1. All right. So now I'm going to come back over and I'm going to go one more step. So, I'm sorry. Yeah, that's correct. I wanted to make sure I didn't mess up on any of my numbers. I did. And that should be a 5.6. Sorry guys, I just don't want to mess up while I'm doing this, because it does have so much math in it that if I make a mistake in it, then it's going to come back and really be difficult to try to fix. So now I'm going to do the final, and that's going to be the 0 point, and that's 0.213 grams of nitrogen. And I'm going to convert this to moles of nitrogen using 14.0 grams per 1 mole. So I get 0.0213 divided by 14, and I get 0.00152. All right, so guys, this is going to be the moles of the nitrogen. So I know that it's composed of carbon, hydrogen, and nitrogen. I'm going to have to divide by the smallest one to get it in a whole number empirical formula. So I'm going to divide everything by 7.62 times 10 to the negative 4th. When I do that, of course, that one is 1. I'm going to divide 7.62 times 10 to the negative 4th. When I do that, this one comes out to be a perfect 6. And then when I do this one, 7.62 times 10 to the negative 4th, always dividing by the smallest whole number, or the smallest mole-mole ratio. And this one comes out to be 1.99, which is close enough to 2 that we can round off. So that means I have 1 carbon, I have 6 hydrogens, and I have 2 nitrogens. So the big difference between this example problem and the one that I did up here was this was a straight up hydrocarbon that only contained carbons and hydrogens. Whereas this problem here had 3 elements. It had carbon, hydrogen, and nitrogen. So whenever I did this, I had to add one more step in here to determine how many grams of the nitrogen was present in my original formula. Then I could take those grams, turn them back into moles, and guys, once you have the moles of each one of the elements that's present, you just divide by the smallest one. That is your mole-mole ratio, and it puts it into smallest whole numbers. C1H6N2. I hope this was useful. Thank you, and I'll see you a little bit later.